In this lesson, we are going to learn about the ambiguous case in the sine law. So the ambiguous case of the sine law can occur when you're given two side lengths and the measure of an angle that's opposite to one of these sides. If the side across from the angle is smaller than the other, then you have the ambiguous case. So this means that you can have not only one triangle, but maybe two triangles given the scenario with that specific angle and those two sides. If we refer back to 6.3 when you did an investigation, you probably figured out that you can create more than one triangle sometimes depending on the sides and the angle that was given. So we're going to go ahead and do questions just like that and consider the possibility of having a second triangle. So here's our example. We're given information about a triangle called DEF. I'm just going to draw a triangle with vertices D, E, and F. I know the side DE is 5 centimeters and the angle D is 80 degrees and side FE is 8 centimeters. So this is our picture of this triangle. We want to solve the triangles. Maybe it's a triangle, or could be also more than one triangle. This means I need to find any missing angle or any missing side. So in other words, whenever you see this question that says solve all triangles, you're going to find all sides and all angles. Alright, so the first thing I can do is probably use a sine law here. With the information that's given to me, I have angle D and side D, and I'm given side F, which means that I can find angle F because I have side F. So we're going to use a sine law to find angle F. So we have sine D over D is equal to sine F over F. D is 80 degrees. And side D is 8 centimeters. We're looking for angle F, and we know the side F is 5. So from here, I'm going to cross multiply and divide. So that's 5 sine 80 is equal to 8 sine F. I'm trying to isolate F, so I'm going to divide both sides by 8. So sine F is 5 sine 80 over 8. And then to find our angle F, I'm going to take the sine inverse of both sides. I'm going to put this into the calculator as sine inverse of 5 times sine 80 divided by 8. You could also just simplify what's inside the bracket first. So once I put 5 times sine 80 divided by 8, I get 0.6155, and then sine inverse of that is 38 degrees. So therefore, angle F is 38 degrees. This is one solution that we have. Now that I have angle F, I could also find the third angle, because we know that if we add 3 angles together in a triangle, this creates 180 degrees altogether. So my next step is to find angle E, which is 180 minus angle D minus angle F. That's 62 degrees, and this is the other answer. Now we're just missing one piece of information, which is side E. That's what we're going to find next. I'm going to use the sine law here, and I will use information about D because this will be the most accurate one since it was given to us in the original question. Then I'm going to fill in our information about our angle D and side D. We just found sine E. E is going to be 62 degrees, and we're looking for side E. So from here, we're going to cross multiply and divide. And since I'm looking for E, I'm going to divide both sides by sine 80. We're going to plug in 8 sine 62 divided by sine 80 in our calculator. You should get 7.2 centimeters as your final answer for side E. So we found angle E, angle F, and side E. So we have all the information about that triangle. Now when it comes to the ambiguous case, we just need to do a check to see if there is even a second angle. And this would be our last step. We already know angle D is for sure an angle in this triangle, and we also know that side F and side D are for sure a part of this triangle. So that means what the first information I found was angle F. So the question is there another version of angle F? So to find another version of angle F, I'm going to look for an angle in quadrant 2 because I know sine is positive in quadrant 2. And we'd usually find an angle in quadrant 2 by taking 180 minus that angle. And that angle that we're using is from the first angle F we found. And that's 142 degrees. So again, to find a possible second angle, we're looking for an angle in quadrant 2. And 142 is an angle in quadrant 2. Now we're going to see if it's actually possible to create a triangle with 142 degrees in it with 80 degrees, because 80 degrees comes from angle D, which is an angle that is for sure in this triangle. But if we add 142 and 80 together, we are going to get over 180 degrees. So it's not possible to form a second triangle, because if we add angle F2 and angle D together, we are already above 180 degrees. So we can't form a second triangle. Because it's greater than 180. So we only have one triangle in this case with angle F, that is 38 degrees. Side E is 7.2 centimeters. And then angle E is 62 degrees. Let's try another example. So in this triangle, we have A, B, and C with the following information. I'm just going to draw this triangle out. So we have side A, it's 24 centimeters. Angle A is 30 degrees. And side B is 42 centimeters. So you want to solve for this triangle and see if there is possibly a second triangle afterwards. Well, with the information that we're given, we have angle A in side A, and we have side B, which means I can find angle B. I'm going to use our sine law. Okay, so angle A is 30 degrees. Side A is 24 centimeters. We're looking for angle B. And side B is 42. So I'm going to cross multiply and divide here, which is 42 sine 30, 24 sine B. I'm looking for B, so I'm going to divide both sides by 24 as my next step to isolate it. And then lastly, to solve for b, I'll take the sine inverse of both sides. We can find what 42 sine 30 divided by 24 is and put that in the calculator. It's going to be about 0.875, and then take the sine inverse of that. Angle B is 61 degrees. So that is one piece of information we found. The second thing we can find is find angle C, because we have angle A and angle B now. And we know that those three angles need to add up to 180 in this triangle. So to solve for angle C, we're going to take 180 and subtract our two other angles. This is going to give us 89 degrees. Now my next step is to find side C. So that's sine C over C, and I'm going to use the information about A because that was the information given to us in the original question. I'm going to fill in the information we know. We just found angle C, which is 89 degrees. Side C is what we're looking for. Angle A is 30, side A is 24. That's 24 sine 89 degrees is C sine 30. And then lastly, we divide both sides by sine 30 to get C by itself. You put this in your calculator and you should get 48 centimeters. So we just finished solving for that one triangle where we have angle B as 61 degrees, angle C as 89 degrees, and side C as 48 centimeters. Now the next thing we're going to do is see if there is a second triangle. Just like the last example, to check to see if there's a second angle, we are going to use angle B to see if we can get this in the second quadrant. So again, we don't want to touch angle A because angle A has to be in this triangle as given to us in the original question. It has to be there. So the first angle we found outside of that would be angle B, and I'm going to see if we can create a second triangle if I put 61 but in the second quadrant. To do that, that's 180 minus 61. This is 119 degrees. So that's angle B2. Let's see if we can find angle C2, which is the second angle would have after that. And to find angle C2, well, we have to know that it's going to be obtuse triangle with angle 119 degrees. One of our sides, or one of our angles has to be 30. So we're kind of looking for this angle to see if it's possible to even have that. And it should be, it's 180 minus 119 minus 30, which is 31 degrees. So that means it's possible to have a triangle because I can create the third angle, which is 31 degrees. So this was B2, C2, and angle A. Also, the sides have to be the same as well. So our side A has to be 24 centimeters and our side B has to be 42. So the only information I'm missing now is side C. Or in other words, C2. This is for your second triangle. So to find that, we're going to use sine C2 over the side C2 is equal to sine A over A. So we know that angle C2 is 31 degrees. We're looking for side C2. Using our second triangle picture, I have 30 degrees for angle A and 24 is side A. We cross multiply and divide. Then divide both sides by sine 30 to get C2 by itself. Put this into your calculator. This is 24.7 centimeters as your final answer. So for your second triangle, we have found all the information for it. E2 is 119 degrees, and we did 180 minus the original angle B to find that. For angle C2, we know that 119 and 30 degrees has to be in the second triangle, so we subtracted that out from 180 to find the angle C2. Then lastly, we found angle C2 using our sine law and the information that we already found for our second triangle. So as a little quick recap, using your sine law, it's possible to have two triangles. You do need to check to see if there is a second triangle or the ambiguous case. In our first example that we've done, we did not have an ambiguous case because our angle over here is already fairly large, and once I add angle D, which is the original angle from this triangle, into this, we're going to get a number that's larger than 180. That means it's not possible to create a triangle with those specific angles. But in the second example, we found that we can find a second triangle because it was possible to create another triangle using the angles that we have found in conjunction with angle A.